Hello everyone, and welcome back to the second video, which is solving absolute value equations. And earlier in the year, I know you've seen this, at least briefly, but I want to remind you about what absolute value means. So if I give you an equation like the absolute value of x equals 3, that means that somehow the number that I plug into the absolute value bars, an absolute value really means distance from 0. So if you think about the word distance, if you take a ruler or a yardstick or anything of that nature and you measure, distance is always a positive measurement. So one number that you could plug into this could be positive 3, because if you plug the absolute value or the distance from 0 to 3 is 3. But also, if you picture on a number line, you can go to 3 or you can go to negative 3. So if I take the absolute value of negative 3, because distance is always positive, if you picture this distance here, that would also be positive 3. So really what I'm saying is that this number in here could be positive or negative to get a positive answer out. Which brings me to number 1. The goal of today is to solve absolute value equations that are either linear, like number 1, or quadratic, like number 2. So let's start with one that we're more familiar with in number 1. And I'm going to use the actual definition, no shortcuts for this video. So what this means is that 6x minus 4 is really just a single number once we figure out what x is. So in here, this number, 6x minus 4, can either be positive or negative to get out a positive 10. And so we really have two cases. We have one case if 6x minus 4 is greater than 0, and a second case if 6x minus 4 is less than 0. So in the first case, if 6x minus 4 is positive, it's going to remain as 6x minus 4, and that distance is going to equal 10. In the second case, this number could be negative in there to get out a positive 10. So if I want to represent this as a negative number, I would write negative 6x minus 4. So you're saying that the whole number is negative, and that is eventually going to be a distance of 10. So if I solve these separately, this one's a little easier. 6x would equal 14, so x would be 14 over 6, or 7/3. So that's one possibility for x. If I distribute the negative on the second one and get negative 6x plus 4 equals 10, and solve, we get negative 6x equals 6. So then here x would be negative 1. So those are our two options. But what's important about this video and many to come is we have a possibility for extraneous solutions, which means that you solved the equation completely correctly, but you do get answers that may not make the equation true. So we need to take the time to go back and check that. So let's start with negative 1. If I plug negative 1 back into the original, that would really be the absolute value of negative 6 minus 4. Does the absolute value of negative 6 minus 4, or the absolute value of negative 10, equal 10? Yes, it does. If I plug in negative 7/3, which would be the absolute value of 6 times 7/3 minus 4. 6 times 7/3 would be 14 minus 4. Does the absolute value of 10 equal 10? Yes, it does. So in this first case, both answers worked. In the second case, where we're dealing with a quadratic example, I want to let you know that I'm going to be doing it in a similar way to number 1. One thing that we need to keep in mind, though, is in order to solve any absolute value equation, the absolute value bars need to be completely alone or isolated. So the first thing I'm going to do is move the 3x and the 6 to the other side. So this equation would become the absolute value of x squared plus 4x is equal to positive 3x and then plus 6 on the other side. So now that the bars are isolated, I can apply the definition of absolute value. So just like the last example, this number, even though it's quadratic, x squared plus 4x really represents a number once we know what x is. So it could either be two cases. If x squared plus 4x is greater than 0 or positive, or if x squared plus 4x is less than 0 or negative, this distance is going to come out to this is going to be either a positive or negative number that will get you your positive distance. So here are our cases. If this is positive, the inside stays the same. So x squared plus 4x equals the distance of 3x plus 6. Or if this number is negative, just like last time, we would have negative x squared plus 4x, and that is going to equal the distance of 3x plus 6. So it looks like both of these we may have to factor. So this one, we moved everything to the other side. We get x squared plus 1x minus 6 equals 0. The two numbers that multiply to be negative 6 and combine to be 1 is plus 3 and minus 2. So two possible answers are negative 3 and 2 on this side. And this one over here, we would distribute the negative and get negative x squared minus 4x equals 3x plus 6. I'm going to move everything to this side again. Negative x squared minus 7x minus 6 equals 0. And I don't know about you, but I'm bothered by the negative in front. So let's multiply or divide everything by negative 1. So it will become x squared plus 7x plus 6 equals 0. And this ends up factoring as well. 6 and 1 adds to be 7, positive, positive. So I again have two possible answers of negative 6 and negative 1. So here's the part that's a bit of a pain, but we have to check our answers. And I'm going to plug it back in to the circled one in red. So if I wanted to check negative 3, I would plug it in everywhere I see an x. You can do it in your calculator, in your head, but you need to check. So negative 3 squared is 9, plus 4 times negative 3. That has to equal 3 times negative 3 plus 6. So let's see if that's true. The absolute value of 9 minus 12, which is the absolute value of negative 3, does that equal negative 9 plus 6? Well, the absolute value of negative 3 is positive 3, and negative 9 plus 6 is negative 3. So this is not true, which means that this answer does not work. However, if I plug 2 into this equation, 2 squared is 4. 4 plus 8 is 12. So the absolute value of 12 is 12. So we have 12 on this side. And on this side of the equation, you have 3 times 2 is 6. 6 plus 6 is 12. So you get 12 equals 12. So this one is for sure an answer. So I want to show you that you could do it mentally or you could write it down. In the same way, you can check these two answers. Let's start with negative 6. If I plug in the absolute value of negative 6 squared is 36, negative 6 times positive 4 is minus 24, does this side equal 3 times negative 6 plus 6? So this side would be negative 12. This side is the absolute value of positive 12, which is 12 equals negative 12, so this answer does not work, just like negative 3. If I plug in negative 1, I know I'm running out of room here, but just to squeeze it in, if I plug in negative 1, that's the absolute value of positive 1 minus 4, so does the absolute value of negative 3 equal 3 times negative 1 plus 6? Well, 3 times negative 1 is negative 3. Negative 3 plus 6 is 3. Does the absolute value of negative 3 equal positive 3? Yes, it does, which means that this is an answer. So my actual only two answers was x equals 2 and x equals negative 1. These two ended up being extraneous. So again, it is very important to check your work. The next two examples I found I think are very good because you need to be able to isolate the absolute value bars and then do the two cases like here. So number 3, the first thing I would do is isolate the absolute value bars and subtract the x squared to the other side and get 1 minus x squared. Then you can apply your two cases. So this is a good one to try. Number 4 is kind of a pain because it's just the way that it's set up that confuses students. But if we think about isolating the variable, and we think about if we keep -3 times the absolute value x on this side and move the x squared and the 70 over, that would become, so if we subtract the x squared, we'd have -x squared. If we added the 70, we'd have plus 70 over here. This one, you could keep going and divide everything by a negative and get 3 absolute value of x equals x squared minus 70. So now I think would be a good time for you to pause the video and feel free to try both of these problems, one of them, but when you come back, I'm going to be showing my work on both of them so that you can see that there are many different ways, or there's many different types of absolute value equations, and it's good to be able to solve them all. So please try what you like, and I will be back soon with my work. All right, guys, feel free to pause the video and copy any of this down that you need. But what I did was the same cases. I said if this number is positive here, then I had x minus 1 equals the distance of 1 minus x squared. If x minus 1 is less than 0 or negative, or if this number is negative in here, I ended up saying that negative x minus 1 equals this distance. I ended up factoring both. This factoring ended up taking out a greatest common factor. I checked my work. These roots were the same, and the only ones that worked were 0 and 1. -2 did not check in either one of these equations. This example was a little strange, but I actually ended up not dividing by 3. And I said if this number was positive and if x was negative, I just kept the 3 and multiplied. So if the x was positive, 3 times positive x would equal this distance, and 3 times negative x would equal this distance. I ended up factoring both. They ended up getting similar answers. And when I went through and either plugged it back into this equation or this one here, I got 10 and -10 to work, but -7 and +7 did not check. So my answers were only 10 and -10. So feel free to ask any follow-up questions either to me or Mr. Lakin or Ms. Schwartz. But I wanted to teach this based on the definition of absolute value, so it's the same type of process each time. Remember that the absolute value bars must be isolated before you keep going. All right, guys, thank you, and I will see you next time for rational equations. Thanks.